This week on Maker Update, weaving wearables, robots cut the cheese, WiPhone, printing with pellets, spine sensors, Biolab in a box, Arduino Portenta, and weeding with AI. Hey, I'm Donald Bell here with a very special edition of Maker Update. We're here in Las Vegas at CES, hoping to find some cool stuff that I think you're gonna like. Let's go check it out. First up in news this week, Arduino announced at CES that they will have a new board available next month called the Portenta H7. The board is a departure for Arduino that is targeted to business customers and IoT products, and it's designed and rated for industrial applications. It's not meant to be a product for makers. In addition to running Arduino code, the Portenta can also be programmed in both Python and JavaScript, and you can set it up to run TensorFlow Lite for machine learning applications. No word yet on pricing. I'm here at the Myant booth with Malad, at a booth that really blew away my expectations on what I thought I would see here at CES. Talk to me about Myant and what Myant does.
Sure thing. So Myant, we are the pioneers in smart textile developments. We're creating a continuous monitoring of individuals through textiles which we all interact with.
So we're talking about textiles. I think that's it's underselling how rad this stuff is, right? Because this is all custom knit textiles with embedded wiring and electronic elements. But what you guys are doing is you're actually weaving the elements into the fabric. Talk to me about that process.
When we do our developments, we begin with the yarns and the core fibers that you described that we weave, we knit, or we embroider. So we can produce yarns, we either extrude them, we either coat them, or we wrap them based on the specific application that we need. And then we go into producing them through a textile production method. And we kind of call it like textile PCBs. The same way that you can print a PCB board, we're doing the same thing through the textile processes to create a PCB on textiles. And second, we're working on another development where we can embed electronics during the knitting process in the fabric. So it's fully sealed and you don't have the need to put or take out electronics, leading to the end objective of, for example, underwear is one of our key product that we're launching this year, where you don't have to have habit change. You just wear your underwear and you're good to go, and the electronics are already embedded inside of it. The first generation, you have to take it out to charge it, but in future generations, it will be all embedded within, and through wireless charging, you just charge the underwear.
This was great. This answered all my questions and more. I'm glad we're getting it on video so I can watch back and watch on slower speed so I can actually take it in. Really appreciate you taking the time to speak with me. I would love to learn more about Roboclette. Tell me about the robot experience behind us.
So this robot is scraping the melted part of the cheese. So it's a raclette cheese. It's famous in Valais. Valais is the region of Switzerland where the IDIAP Research Institute is. It's a research institute that developed this technology. I'm responsible of the robotics group there. And behind that, be careful, the robot is moving. So behind this, there is a technology that is called learning from demonstration. It's a technique that allows people to demonstrate a task to the robot, and then the robot can reproduce this task. So it's a very intuitive interface for people to train the robot to do some tasks.
So how was this particular robot trained? Was it trained by hand or using like a computer input?
So this one is trained by hand. So it means that you can grab the arm of the robot, move it through the different steps of the task, and it's collecting information about the movement and about the force. And if you do that several times, the robot will progressively understand what are the most important aspects in the movement. Because some aspects will need to be precise, some others might have more options or more variations that are possible.
Great. Well, it's a really fun demo. I appreciate you taking the time to talk with me here.
Thank you.
I'm here with Ben. Ben's got a WiPhone. Tell me about the WiPhone.
So the WiPhone is the phone that an engineer or a hobbyist might want but doesn't have right now, because smartphones are too integrated and you can't really hack into them. If you want to repurpose a phone, it's just not really easy or sometimes even possible. Hardware and the software are both too integrated, too complicated to get into. So I wanted a phone that I could adapt or use for other purposes. I also wanted a phone that doesn't have all the bells and whistles of a smartphone that I don't like tracking and that sort of thing. So I made this phone. It's basically a VoIP phone that runs the ESP32 processor. You can open the whole operating system in the Arduino IDE, change it how you want, You can replace the back of the phone with what we call daughter boards. If you're used to the Arduino system with stackable boards, it's similar except it's basically just one board. These pogo pins connect you directly to the ESP32 processor, and if you add your own board, now you got a device that's similar to a phone but does what you want.
Well, it looks really great, and I'm excited to see it come out, and I hope it does really well.
Yep.
I'm here with Matthew, and the name of the company is Wreath 3D, correct?
It is.
All right. All right, and then tell me about this beautiful giant 3D printer that's behind us.
Yeah, absolutely. So my name's Matthew Fiedler, and I'm CTO and co-founder of Wreath 3D. We're based out of Houston, Texas. We wanted to make 3D printing accessible to people all over the world. And so we had to do that by bringing down the cost and opening up the accessibility, making an open source product, so open hardware, open software, and really get the community involved in the work that we're doing. And we focused on large scale. So we have two primary types of 3D printers. The one behind us is our Gigabot X platform. And what's really unique about it is that we can print from granulated or ground up plastic. And so that could be recycled material. In fact, behind me and above me, you can see on the machine that's blue hopper. That's actually printed from 100% recycled water bottles. And that hopper actually is part of the machine where we pour in our plastic granules or our recycled material, and we can print directly from that. And we can actually do polymer science right in our hopper too, right? So if we stay with the granules and say you can add chain extenders, modifiers, plasticizers, you can start to do chemistry right in the hopper and print out and modify the physical properties of the material. Plus, if you make filament, even recycled plastic and make filament, every time you go through a heat cycle, you're degrading that plastic a little bit. So you can only recycle plastic so many times before you need to start to bolster it up a little bit. So going straight from pellets to print is the most direct route. And we saw plastic waste everywhere. And we said, how come we can't take that plastic waste and recycle it, put it into a 3D printer, and allow people to print things that they need, say, in the developing world. So we can actually create new economies that never existed before by giving them a tool.
Great. Well, it's very exciting to see, and I appreciate you taking the time to talk with me.
Oh, thanks so much. It's been a pleasure. Thank you.
I'm here at a booth for a product called Liif. It's a life-saving technology. I'm really interested in the product, and hopefully you can talk to me about this a little bit, but I'm also interested in the sensor technology behind it, which I think our audience will appreciate. Talk to me first about Liif as a product.
Sure, okay, so what we did here is we built a crash detection system for gravity sports. Everything that goes downhill, like snowboarding, downhill mountain biking and skiing. And the basic idea is pretty easy. So we detect severe crashes, and we'll trigger an automated distress call. And we do this by combining two types of signals. We got for once an IMU included in here, but also our flexible force sensors, which are built in the strap and in this neck area right here. So we can really reliably classify a severe crash and do not give too many false positives.
Now talk to me about the flex sensor itself, because this isn't just the conventional kind of flex sensor I've come across in Arduino kits. This is something that you make.
Yeah, that's true. So the flex sensor is called Plion, like the technology base, and it's made by Tectirion, the company we originally worked for. And it's a flexible force sensor, which is capable of detecting approximation, touch, and actual force you apply to it in an analog signal. It's based off silicon and a printed electronics PET plastic. It's very flexible. It's made for every kind of wearable or dynamic interface you could imagine. And the special thing about it is that it's a phenomenon we call true zero, because commercially available force sensors, if you buy them and you bend them, they might be mechanically flexible, but what our sensor does, it kind of does not cut off any measurement range. So we got a true zero even under bending, and we got the full range available for measurement.
Thanks so much for talking to me. I'm here with Demetrius and the Feeleth, a Biolab on your table. Talk to me about Feeleth.
Well, we have a desktop Biolab kit. It's designed to replace going to the lab, finding a lab, figuring out if you need a PhD to get into it or not. Instead, we've provided all of the tools that you will need in order to run your own bio experiments and start learning.
This is really cool, and the technology underneath it is really all kind of familiar maker technology in some sense. There's a Raspberry Pi at the heart of the system, correct?
That is correct. We have the Raspberry Pi as our main board. It handles all of the modules. It tells them what they need to do based on what the user tells us through our user interface.
All right, and then talk to me about the modules a little bit, because those aren't familiar territory for a lot of makers, right? So what kinds of modules are included in the system?
Well, we have 2 incubators, a freezer, a thermocycler for growing DNA. We have a gel dock so you can visualize that. And then we have a centrifuge for separating out your different components. And finally, a spectrometer so you can take a look at the different wavelength properties that it has.
And if someone gets their hands on one of these, what kinds of things could they start tinkering with right out of the box?
I mean, they could, if they wanted to, they could get started with testing their own blood type, get a swab in there and see what they have, or if they wanted to see whether their food has GMO in it or not, that would be something that they could easily do from the comfort of their own home.
It's cool because there's a lot of talk about STEAM in education, but something like this seems like, in addition to the 3D printer and the laser cutter, you should have your own desktop biolab, right?
Fantastic.
I'm here with Martin and a robot that is going to pave the way for a new future for sustainable agriculture and robotics helping us to weed and pick our crops. So let's talk about Odd.Bot.
Yes, so what we have here is a robot that can detect and distinguish both the weeds and the crops and remove the weeds mechanically. So instead of using hand weeders or using chemicals, which can be potentially harmful, this robot can do weeding mechanically for you. So that's what you see here on the detection algorithm, which we have trained with thousands and thousands of pictures of carrots and weeds. So we're now at the level that we can properly distinguish the two. And the Delta Arm robot, which we have here, is a miniature version, fully 3D printed with Arduinos. And we simulate here that the robot drives over the crop field. Therefore we have printed an image of the field on this conveyor belt. And the robot, the Delta Arm, is moving towards the weed to pick it up and get it out.
Right. I think it's a great idea, and you also have another idea here too that we'll take a look at soon. That's a beach cleanup robot. Is it using some of the same technology?
Yes. So again, instead of being able to detect and distinguish weeds from crops, it can detect small litter like cigarette butts and distinguish them from shells and other debris on the beach, and clean the beach mechanically as well.
Well, I think it's an exciting combination of both robotics and machine learning, and I think it'll be really cool to see how this can help us have more sustainable agriculture. All right, so there you go. That is CES 2020. From my perspective, the stuff I thought was cool. I hope you liked it. A huge thanks to DigiKey Electronics for making this special episode possible. Let me know down in the comments what you thought of it, and we'll be back to the regular Maker Update episode format next week. But until then, thanks for watching, and I'll see you soon.